So we're going to talk a little bit about the event-driven autoscaling for Java application for the next 59 minutes. So my name is Daniel. I'm working for Red Hat, as you can see, and I'm working for pretty much a Quarkus stuff. And then, of course, most likely Java, like a Quarkus, Spring Boot, and a bunch of the other technology. And then I spend a lot of time to bring more Java application into cloud, such as Kubernetes, of course, public cloud, like Amazon, Google, and Microsoft. Specifically, serverless and service mesh and GitOps, like Argo City and pipeline, things like that. So one of my duties is CNCF ambassador, so that's why I gotta spend some time to KubeCon, review some proposal, and then some hosting track chair, and then the other stuff. So my main goal to help many people, not only developer, but also SRE or platform engineer, how to build their own like a cloud-native application and architecture. So we for example, we have a bunch of the choices. Like when you go to CNCF, some page, and there are more than 1,000 projects. And then what kind of tools and project I need to use that to build my a CI/CD pipeline on top of the Kubernetes or a serverless function. So that's I try to spend time and effort to evangelize the people. And here's my contact information. You can follow my Twitter, and then you can subscribe my YouTube channel. And then here's my Git repository. You can steal whatever you need from my Git repo. And then if you got some broken, and then just let me know. I'm more than happy to fix that. So how many people have some hands-on experience with the Kubernetes, not just looking at? 1, 2, all right, yes or no? Okay, I'm gonna accept the challenge. Okay, this should be fun, so interesting. Okay, I assume no one actually have some experience with Kubernetes, but you already know what Kubernetes is, right? Okay, because everybody's doing Kubernetes. So that's my challenge actually when I hosting the KubeCon, because a lot of people already know Kubernetes, but no one actually have some experience the one-on-one session. Everybody's assuming, you know Kubernetes, which means you know how to use that, but that's not true. So this is some challenges. So the beauty of the Kubernetes, you can have an auto-scaling feature based on AKA HPA, horizontal power autoscaler, based on the CPU memory utilization. So in a traditionally, IT ops people actually measure and monitor your infrastructure, like a CPU, memory, or some specific seasonality, and then they decide, okay, we need to buy more CPU and memory and the disk drive or something like that. And then they increase, we can call that scale up, and then after event, you can scale down. So that's traditional way how to operate your infrastructure. And the Kubernetes actually game changer. The Kubernetes automatically orchestrate your application workload and then monitor and then utilization, and it automatically scale out and in rather than up and down. So with that Kubernetes, for example, here is just some retail services, and then you have a bunch of the microservices, some of them Java, some of them Python, Go, and then that application should be scaled out based on incoming network traffic. So luckily, we have a Kubernetes. And the Kubernetes orchestrate the kind of stuff based on HPA, like you said. But in reality, it's something different. Let me show you. So in the reality, so the application actually not standalone. Even if microservices is standalone or stateless, say, but that is too ideal. So in reality, the application distribute and then connect to the others, and then call RESTful API or some messaging broker, things like that. Or even sometimes your Spring Boot also connect to your Oracle database to retrieve data and print the data, things like that. So with the event-driven application or more like some reactive application, so you have a bunch of the external services consume the event streaming data. For example, you can see here like a Kafka, one of the popular thing, and then metric data from Prometheus, and then Azure Monitor, like a public cloud, and a cloud watching in AWS. So based on that metric data, you need to decide, okay, my application scale to 10 from 1 based on Prometheus metric or the Apache Kafka or Apache Pulsar, whatever you call that. And then like if you run your application on like an Azure cloud, and then you need to maybe monitor or observe the Azure like a watch, things like that, and monitor. And then you can decide, okay, we need to scale in and out. However, the Kubernetes actually, HPA is pretty much focused on the resource utilization rather than the external services. So that's the challenge for many people who really want to use Kubernetes. Regardless of you're going to use Kubernetes on-prem or some EKS, AKS, or even Alibaba Cloud, doesn't matter. As long as you want to use Kubernetes and with the external services, you gotta face this challenge. So how to solve that? So this is some very known solution. You can create some auto-scaling infrastructure with some custom metric adapter. As you can see, okay, I can create some in a Kubernetes perspective. You can create like a customer resource definition, like a CRD, and then create a CR for the instance, and then that incorporate your external service into your application. And then that customer metric adapter, just some kind of liaison between your application and the external services. And now, so okay, I'm gonna let you know when you're gonna do scale in and out. And then like I'm gonna connect to Prometheus, and then connect to AWS CloudWatch or Azure Monitor. But there's no adapter connected directly the Apache Kafka right now. But this is not best solution because when you deploy multiple services, remember that this retail service is one namespace, which is one project. Because one project have multiple services and multiple microservices, and not only one. It's not hello world in the production, right? So you have a multiple application in the one namespace, like this is a retail, this is the other domain. The problem is you can only enable one metric adapter at once, not multiple. But the second problem is here. Okay, for example, my order services depends on Apache Kafka. However, my inventory service depends on the AWS CloudWatch. How to do that? Because you can only enable one adapter at once. So that's the problem. That's the KDA project actually came out. So KDA literally the acronym Kubernetes Event-Driven Autoscaling. So this is an honorable CNCF project and a 100% open source project, and Microsoft and Red Hat jump into this project, invented a lot. And then it's super simple. You don't need to change anything. So you already deployed that Microsoft application on Kubernetes, and then you just create one some resources based on the KDA specification. We call it scaled object or scaled job, and then that is keep monitoring the external services and then later decide, okay, now time to scale in and out, just like that. So this is some history, and then you can install the KDA with the Helm chart for developer preference, and then the operator is more SRE, platform engineer preference. And then there are more than 61 built-in scaler, which is you can add on your Kubernetes. Let me show you that architecture, how to redesign. So I know this is not super familiar with the developers, but you need to know this kind of architecture is pretty much good for you when you develop reactive application, because you already spend a lot of time and effort to develop reactive application regardless of Spring Boot and Quarkus. But when you deploy your application to Kubernetes and then product, and then some of your operation team guy, hey, I got some problem. So your application, maybe some guy just stuck, and then there are super high spike node, and then doesn't work anymore. But that's not my problem, actually. My application super awesome, and then it's optimized well, but some architecture actually not control that, because the this application 100% optimized, let's say like a 99%, but this platform actually scaled out, and my application already added some business logic, like a concurrency in a reactive way, and now it's your job to make a scale out. My job is done. So maybe you can tell them, can you take a look at this kind of stuff? And then this is how to redesign your auto-scaling infrastructure with the Kata. Now you can see, big difference thing is that the HPA is gone. HPA previously mapped to each microservices, but it just got rid of that. And then the Kata all control more than 60 the scalar, and then you can actually enable multiple external services at the same time in the single namespace. This is really awesome. And then the Kata only handle from 0 to 1, 1 to 0. But in reality, one container is not good enough for like some maybe millions of event storming data coming to your one single application pod. That's going to be disaster. So that's why Kata actually poking HPA, hey, I'm just my job done, and then now your turn, and then HPA, okay, I'm going to scale out from 1 to 10,000, things like that. So this is a really good architecture, but so this is just some overview how it works and in Kata. So it's not super complicated. So as you can see, there are some metrics adapter, controller, scalar, and then so as I can say, it's managed workload from 0 to 1, and then there's no more data in the process. It's just back to the 0. And then here's some example, the scaled object. You only need to create this one. And then scale object is setting on what is the target resources on top of the Kubernetes, which is the deployment or a batch job, things like that. And then what is the trigger? So you can trigger, set it up Apache Kafka or the CloudWatch or the Prometheus or RabbitMQ based on more than 60 scalar object here. So I'm going to give some quick question is, what about the serverless auto-scaling? Because as I mentioned earlier, Kata is so event-driven scale in and out, but you don't need to change the existing application deployment specification, which means that is not serverless because you're running all the time, 24/7. But the serverless is a totally different behavior, just like imagine Amazon Lambda. How many people actually try to use Amazon Lambda buffer? Okay, better than Kubernetes. Great. So when you deploy your application, Amazon Lambda, and it will be running on some period of time, and after that, without no incoming traffic, it will go down. And then just like a hibernate, and you can say idle. And then once you just call and invoke that application using like a RESTful API or so click on some page on web UI, it automatically restart. And they say cold start. It takes some couple seconds. Maybe there's a big challenge. Why don't you don't want to use the serverless because it's too long. Anyway, so that is serverless. So many people wanted to use Kubernetes. However, how to handle serverless on top of the Kubernetes? So rather than go to Amazon or go to Azure or go to Google platforms. So Knative, another project. But when I try to talk a little bit about Knative, Kata is pretty similar. Sometimes I'm really confused to pronounce Kata, Knative. So, but this is just some bullet point of what kind of things different between Kata and Knative. So Knative, you need to rewrite your Kubernetes resources, deploy your application as a serverless or a function on top of the Kubernetes. However, Kata, you don't need to change anything existing application. Just the set it up, where is the trigger and where is the external services and where is the target resources on Kubernetes. And then there are something different thing. I'm going to a little bit explain a little bit detail in the next couple of demos. So today I'm going to try to showcase 4 different demos. live demos. I got a finger crossed and should pray the demo God double time. But so first use case. So it's the four use cases and four demo actually. I'm going to try to showcase how to keep evolving your event-driven application architecture, specifically using Java and on top of the Kubernetes. So this is a very traditional way on Kubernetes running application. As you can see, I'm going to use Apache Kafka as one of the external services. And then I'm going to try to generate the dummy record in Apache Kafka, 5 million dummy data in the every single second. I mean, in every single second, one dummy record is generated, and then in the end, in the 5 million data. And then that data will be consuming on Java application. I'm going to use Quarkus. So the reason why I'm using Quarkus, I'm going to show that just a bit later. So as I already mentioned earlier, so Kubernetes using HPA, the horizontal part autoscaler based on CPU memory. So let's jump into demo. If you already joined the Eric's session, you may be familiar with this sticker, things like that, right? It's a Quarkus Rockstar sticker. So it's actually a guitarist, things like that. Okay, anyway. So I'm going to use the OpenShift, which is some Red Hat version Kubernetes. And I already installed an Apache Kafka using operator. So this is my Kafka cluster, and then here's my project. First project, Kafka-HPA. And then here's my example project, and then my ID too. Everybody's good to see that while you want to make it bigger? Okay, good. Just in case, I'm going to do it a little bit bigger. So this is the application based on Quarkus, and then in Quarkus is I'm going to try to using latest version 2.16.6. We just released 2 days ago, and then we are preparing to release Quarkus 3 coming up soon enough. There are a bunch of new exciting features, like for example, we will integrate virtual thread project room, and then support the microprofile 6 and Jacquard EE10. And then more awesome features coming up soon. Stay tuned. So this application pretty much is simple. As you can see, one just Java method, and then just event consumer. So event consumer just consuming the data from my topic, which is my topic name from Apache Kafka. And then I just print out and I just print out logs that dummy data. It's pretty simple. So this is the first reason why I'm using Quarkus. So I'm pretty sure you guys are Spring developer and then Spring experience. And then if you got some challenge to rewrite your existing non-reactive Spring app to reactive Spring app, you need to use Spring Reactive and then some ecosystem, for example, Spring Integration, more Spring Cloud, and Spring Function, etc., a bunch of stuff. It's not about just a couple of line change, it's the whole application you need to rewrite it. And the Quarkus actually was born built on reactive engine, Borax and Netty. So which means Quarkus provides 100% reactive behavior. You can also develop non-reactive application on top of the Quarkus as well. So it's pretty simple. So with the relevant dependency, we could say Quarkus extension, and then you can edit some relevant annotation, for example, annotation incoming, and with the topic name, the Quarkus method automatically treat your like a messaging, like a JSON format stuff. And then when you edit like outgoing annotation, you're just sending out message to target like a messaging server like Kafka or RabbitMQ, things like that. And you can also set up channel. So Eric actually wrote a book and then compares Spring versus Quarkus with some interesting and major use cases, like how to develop reactive programming, and then RESTful API, how to develop the CRUD, like a data transaction, and then how to deploy cloud. This is the way how Spring Boot works, and this is the way how Quarkus works. We're not going to say, yeah, Quarkus always do better than Spring Boot, but we just let you know and figure it out after reading the book, and then you will figure out, okay, this case, and the Quarkus is pretty much better. Maybe this case we're gonna read with the Spring Boot. Yeah. So there is Eric, so you can ask him. The book is free downloadable. All right. So that's a pretty simple example application. And then when you go to application property, you can set it up like a YAML file. I just set it up, my topic, the Bootstrap server. So this is exactly not fully qualified domain name because I already deployed to install Apache Kafka as container on the Kubernetes. And then I'm going to deploy same application in the same namespace. So I just need to Kubernetes service name to connect to my Kafka Bootstrap server. So that's why this is pretty simple. And then here's a bunch of the OpenShift and the Kubernetes related configuration. So I'm going to deploy Kubernetes this application, and then some of the request limit configuration to smoothly scale in and out. Okay, so I'm going to change my terminal window. I'm going to make sure I'm into right project, Kafka Kata here. So you can deploy in a packaging application with the Maven command line or Gradle and then Quarkus CLI. And then whatever you need to use that, and then the Quarkus OpenShift extension allows you packaging application like a job file. Quarkus said faster because we override class loader, so make it faster. We already know where the class path is, so that's why we're not going to say fastjar or uberjar. But you can also packaging uberjar as well, though. And then after packaging job file, we containerize the application like making image, container image, and then deploy to push that image into container registry. Today I'm going to use existing integrate container registry inside the OpenShift cluster, but you can push that container registry into like a Google container registry or Quay.io or Docker Hub, and then Azure container registry, whatever you want. And then last time, the Quarkus automatically generate Kubernetes resources. When you go to target directory, you can find the Kubernetes directory, and you can find YAML and JSON. This is all about Kubernetes plus OpenShift resources or many faster. So for developer standpoint, that's the second reason why I'm using Quarkus today. You don't need to run Docker CLI. You don't need to write Docker file. And you don't need to write like a YAML file, like a Kubernetes resources. You cannot remember all of that. Maybe you can copy and paste the existing project, existing resources, but Quarkus automatically that kind of stuff. You don't even need to use run like a CLI, like a kubectl and Docker CLI. It's automatically done that and then deploy to OpenShift cluster. Let's take a look at that, and then you can see that the Quarkus application deploy. And then when I go to like a view logs, and then I can see my application here to 16.6, and then it takes 5 seconds startup and a bunch of the capability. Here is Kafka client, and the REST EG to Jackson, and the Kubernetes, and the things like that. And then, as you can see here, my application is one part right now, one, and then I can see the up and down arrow, which means I can manually up and down, the increase and decrease. But today I'm gonna try to more focus on the auto-scaling stuff. So let's go back to terminal, and I'm gonna try to add auto-scaling to my application. Here is the min-max 110 and the CPU utilization 70%. It's a pretty much a realistic use case. And then when I back to the UI, and now you can see auto-scaling is to one part. Now it's all ready to go. And then when I back to my project, and then luckily the Apache Kafka actually include the performance test bash script inside the Kafka by default, which is a Kafka project performance test bash script. I'm going to try to use this kind of stuff rather than some third-party performance tool. And as you can see, I'm going to use this topic name, my topic, and then like a throughput is 1 million, and then it's at the 1 second. Every 1 second, I'm going to generate dummy record, and then just dummy record generate in the Kafka topic, and then Quarkus application consume that Kafka topic 1 million and then 5 parallel, which means 5 million in the end. So I just copy. You can using OC command line or kubectl or you can WebUI because the OpenShift cluster provide the fantastic WebUI. I just create new batch job here. And then as you can see, so the job is just created and then go to here, resources, the 5 pod just created. And then when I click on one of them, and then now you can see, so dummy job just created, and then it's every single second. So a little bit, there's some latency, so some kind of UI rendering right now. So, and then when you go to my application, and here's the horizontal part of scalar. And then our target CPU is 70%. However, so current is 0, nothing in there. However, let's take a look at my Quarkus application. What are you doing right now? I got a super crazy busy to process the millions of data, but the stupid Kubernetes just say 0, nothing. So that's the big challenge. The HPA is not perfect for your event-driven application. So you need to talk to your ops team and DevOps engineer as long as they want to use, and they 100% trust the Kubernetes HPA. So that is not a case for event-driven application. Even if you can see that the line over here is already 36,000. However, when you go back to application, now you can see that it's still 1. Because when I go back to HPA, it's still nothing. So that's the problem. So let's just repeat it a few more, give some time, because I think it's the HPA, oh, give me a break. I need some time, calculate it, this kind of stuff. Okay, fair enough. And then let's go back to slide, and then let's try to find a better way how to make it better. So it's time to redesign with the Kata. And a little bit different architecture here, as you can see. We have Kafka also an application Quarkus. And then Kata just jump into this architecture to redesign. And then Kata, as you can see, just keep gathering your metric data. That's why Kata say pull approach rather than push. Because there's just getting data from Kafka. And then in the meantime, application still consuming data to process, just the Quarkus stage up. And then it's time to scale, and then just let know your application, yeah, okay, buddy, you gotta scale up, like based on the maximum capacity, like 10,000, whatever. So let's go back to the demo environment. I'm gonna switch to the other project is here, Kafka Kata here. As you can see, it's the same Kafka thing, and then nothing application. And then let's go back to my project. In this time, I'm going to just predefine my deployment config here, and then the targeting bootstrap server and environment variable, and the same application already packaging and containerized the application and push it into query registry. Just I want to show you some different way how to deploy application to Kubernetes as a developer experience, and then just deploy that and back to the topology view. And then my Quarkus application is here, and then try to view logs, and then it's just coming up to connect to my topic Kafka. It's the same thing, and the same version. I'm not gonna treat fake some stuff. Here the 2.16.6, and then like a 5 seconds to start up. Okay, now I'm gonna try to create one thing, the scale object. As you can see, the targeting. Here is the targeting. It's the same name of deployment. When you go back to here, the same name, Quarkus EDA-demo. And then what is trigger? My Kafka bootstrap server. This is the way. And then you can use the kubectl or OC command line or WebUI, whatever you want. And then now you can see that automatically create the HPA. Kafka Kata actually create this one. And then so it auto-scaling setting up. So pretty much it's simple. And then I'm going to try to using the same performance test bash script here. and then create here, back to here, the job is not just created, and then file, and then back to the Quarkus, and then just click on here. Now the Quarkus is just starting, working pretty much hard, and then it takes some time. It's just really faster than just normal HPA to scale out. Now you can see that it's already scaled out to 4. So let's go back to stupid HPA thing, and then go back to HPA, and its job is already done. It's already 5 million data into Kafka. What happened? Oh, it's only 2. Because when I go to HPA, the measurement, and now you can see, okay, target 70%. We just exceeded 70%. That's why we scale just 1 more. And then 2 pod, still crazy busy, gonna be mad. But that's the reason why we need to think about the event-driven stuff. And then go to Kata, and then you can see that now we have a 10 pod here. So you can go to here, it's 10 pod. As you can see, autoscale to 10 pod. So that's the reason why event-driven application, doesn't matter Quarkus or Spring Boot, even Node.js, Python, as long as you're going to Kubernetes, you need to think about this design, Kata. But this is not serverless. It's just general and normal application. So let's go back to slide, and then try to think about how to handle serverless application. Because serverless was born connect to event-driven. So Knative project also Knative eventing component and then Knative serving component. Knative serving allows you to deploy your application as a serverless service. And then that serverless is going down, up and down based on event-driven some happening. So that's why Knative eventing allows you go up and down with the services and event service. So that's why you can see Kafka is still there. And here's the Knative eventing infrastructure. You can set it up Kafka source or some messaging broker. There are a bunch of stuff. And then this kind of some liaison between Kafka and the actual Knative services application. And then it's just pass through your event messaging from Kafka or another external services into your actual application. And then in the meantime, Kafka is a Knative. Knative also have their own autoscaler. And then they decide, okay, this is the time to scale up and down or in and out. So that's why it's not scrapping data from Kafka, not like Kata. So that's why Knative say, yeah, we're gonna just push them. Yeah, you're gonna do scale in and out. So that's why a little bit more pushing model. And then the Knative also adopt a cloud event. So cloud events is more like a standard way to define your event messaging format. So some of the applications, not only Java, Python, or things like that, maybe you prefer to use a JSON format, or you're going to use the binary or protobuf. But the problem is how to communicate it between and among others different messaging format. The traditionally you're going to have some camel or integration stuff, and then messaging platforms, and then cloud event is provide a standard messaging format. And then you can consume based on JSON or protobuf and binary, etc. So go to the third demo, and then I'm going to switch it back to new namespace, Kafka native, Knative, and then so this is the also the same Kafka topic here. And then let's go back to my project here. So I have another project to Knative. And the Knative project, you actually rewrite your application itself to control Knative event. But this is a very simple. There is no business logic at this moment. That's why you cannot find that. But you have to rewrite your application to handle cloud event messaging, even if you're going to keep using the JSON format. And then the resources go to, you can set it up, the you cannot find any kind of Kafka compilation. Previously, we have a Kafka compilation in the application side. You need to specify where is my Apache Kafka Bootstrap server. But you cannot find any more because of knative eventing, the Kafka source will handle that kind of thing. So, and then this is the third reason I'm going to use Quarkus state because you can set it up. The deployment target is knative. So previously we were using OpenShift, and it automatically generates OpenShift resources. If you set it up Kubernetes, it will generate kubernetes.yaml, kubernetes.json. And then when you set it up knative, it automatically generates knative.json or YAML file. You don't need to rewrite. As I mentioned, one of the challenges to use knative, you need to rewrite the resources file, like a YAML file. But you don't need to that because Quarkus take care of that for you. And then let's go back to terminal, and I'm going to try to change my project, knative, and then also I need to project root here, and then I'm going to try to rerun one more time to deploy my application Quarkus. So it's the same experience for developer. I just using my prepared packaging tool, Maven, Gradle, for me, Quarkus CLI, because I don't want to remember all kind of detailed argument and parameter when you're using Maven or Gradle. So Quarkus automatically provides that kind of some shortened command line and then auto completion, which is a pretty convenient for me. Specifically library demo. And then once you deploy this application to Kubernetes, and then when I go back to here, and it will pop up here. And then after a few seconds, the application will be going down, just like Amazon Lambda. So I just deploy that thing, okay. And then back to the topology view. Now I'm going to new application is just pop up here. And then when you go to the one part, and then go to take a view logs, make sure the same version of a Quarkus. And then here is just a bunch of the extension and the capability I already include. And then the default knative service scaled down to 0 time is 30 seconds. So after 30 seconds without any incoming traffic, this application scaled down to 0, just like Amazon Lambda on Azure function. So let's give it a moment, and in the meantime, I'm going to try to change this Oracle logo to Quarkus just for fun. Because just imagine that you got a bunch of the microservices in the same namespace, and then it's obviously, okay, this application Java, and specifically Quarkus and Spring Boot, and then like a Node.js and a Python, even database and a cache. So it's pretty much easier. You can realize the application portfolio in the topology view. Okay, it's a little bit dark gray, navy color means that we're going to terminate right now. And then when I go back to, and then I need to add the Kafka source for the eventing. So this is that eventing. As you can see, I just set it up. The sync means my application deployment name. The sync means I'm going to print this messaging where I print this messaging, like a source. So that is my application. And what is the Bootstrap server? Here is a Kafka thing. That's all I need. I don't need to anymore set it up that configuration of my application side. So this is a really knative feature. And then when I create that Kafka source into my Quarkus application, and now you can see the Kafka is attaching my application. Now I'm going to go back to my application, and then I'm going to try to use the same performance bash script in this project as well. And then you can see the application right away scale up because the knative already know, okay, so I got a bunch of the incoming application. Now you can see, wow, there are many messaging from Kafka. And then now it's the time to wake up, just like a serverless. And the problem is, As you saw, the Kata make it like a more than 1, like a 10, or depends on how big, and then the maximum capacity. So, but the K-enable problem, you can only scale out to 1. It's a serverless still, however, just 1, from 0 to 1, that's it. So 1 serverless behavior, but 1 container Quarkus going crazy, just like a HPA stuff. And then after the 1 Java application have processed all 5 million data, and then it's going to dead, like just 0. But it takes a while. In the meantime, your end user maybe, I got some latency, so I need to click on some page, but nothing happened, just a wipe, and then totally they going to the mad. So that's literally our last design, and this is our session title. So how about event-driven serverless, not just general serverless application, specifically autoscaling? So many people ask me, hey Dan, I understand that Knative and Kata and Kubernetes underneath technology. Sometimes I'm confused, and then which one I need to select for autoscaling with my event-driven application, not only Java, but also like a Python Go. So I can't be 100% sure. Sometimes I need to pick it up, Kata or Knative. It's kind of some problem. So, but we have a new sandbox project, integrate Kata and Knative. You don't need to worry about anymore. So new some upstream, some community project, it actually tried some effort to merge Knative and Kata. So Kata just use the auto-scaling capability with the Knative eventing infrastructure. And then, so this is some really complicated architecture, but this is super cool. So Kata, just like usually, monitor and scrap data from Kafka topic. And then the previously Kata asked application directly, okay, it's time to scale up. However, in this case, we integrate Kata and Knative. So Kata call to Knative eventing, in this case, Kafka source. It could be RabbitMQ or Redis Stream or the Amazon and SQS, things like that. And then the Kafka source send the message to your actual application. And then Knative actually control your actual application at the same time. So what happened? So now the middle layer Knative eventing, Kafka source also scale out, as well as the actual application also scale out at the same time. So 2 layers scale out, multiple multiplex, and super fast. So let me go back to the application demo here. So it's still 1, and I'm gonna change my project, my last project. So far so good. So it's a finger crossed in the last demo. And then back to the application, and I'm gonna try to use the same thing, but one thing is I'm gonna change it to the container image group means the namespace, like a project name. And then here's a fourth reason why I'm using Quarkus today. So Quarkus actually says on Knative compilation rather than YAML directly. So automatically generate YAML with this compilation. As you can see, so min-max, and then the targeting, something like that. So I just save the compilation. Back to the terminal. I'm going to change my project, Kafka, and Kata, and Knative. Okay. So one typo here. Oh. So not project name. Oh, it's a Kata and Knative. Kata and Knative. All right, I'm here, and I'm going to try to build once again my application. And then just in case, so Docker file it's automatically generated in Quarkus project as well. When you go to main directory, you can find the Docker file, 4 different Docker files. For JVM, when you run the application on top of the JVM, so Docker file provided that. And as I mentioned earlier, the Quarkus by default generate fast jar, so which means it's a different target directory. So when you're using Spring Boot, you have the thin jar or uber jar just right under target directory. And now Quarkus actually under target and the one other layer, Quarkus-app directory. But you could set it up some compilation. I'm going to use packaging like a legacy jar, and then you automatically generate like a legacy jar and just right under target directory. The reason why, because some of the some platform, they only looking at right under target directory rather than 2 level. That's the case, we're going to provide that kind of feature in the Quarkus side. And then this is the legacy jar. As you can see, only different thing is here, just under the target directory, you can see the run jar. And then native. So Quarkus also provides native compilation running on GraalVM. So 2 choices, and then you can run Quarkus as Java or the GraalVM. And then this is just some kind of thing. And then you can also use really keen to optimize and make it smaller as much as possible. And then in case we're gonna micro image as a base image, it's pretty much smaller than just general native image. I mean, when you containerize the application. Okay, back to the terminal. Yeah, we deployed that. And then back to the application. Now we gotta have an application. And now next step, I'm gonna do the same thing, create a Kafka source to attach in my application. So in this case, we have a little bit different thing here. So we can add here the Kata compilation here with the Knative. So this is literally how the Knative and Kata integration works with this annotation here. So, and then here is a min-max and 0 to 10, not 1 to 10, because it's still serverless application. After your job done, you need to be idle, like a 0, not 1. And then I just copy that, and then back to the my application, and then try to attach it, things like that. Okay, I attached it. In the meantime, application is terminating and slowing down. Okay, so it's time to run this kind of stuff again. Okay, let me try to one more time add my application to make sure this is a Quarkus application. And then, so creating one, batch job, and then you can batch job, just create a file and just running. And then let's take a look at my serverless application when it actually will scale out. Then the application here, yeah, now you can see the Quarkus, it just scale out right away. And then it already scaled out to 4. It's faster than just only Kata, as well as serverless application. The another different thing is, as you mentioned earlier, it also scaled out the Kafka source. The previous Kafka source version running on multiple containers, but now it's one container, and then inside one container, but inside the container there are multiple processes. There are the one process default, and then we scale out the multiple processes inside the container as well as actual application. That's why you can see the Kata was scaled out from 1 to 4 and 10. But this is a 0 to 4, and then it's more dynamically scaled out and in, just to literally keep monitoring your event-driven messaging. So which means it's pretty much efficient, and then you can save your infrastructure money, things like that. So the big reason why you need to use serverless, because you want to save your money. Because without your workload, why don't we keep running this application 24/7? That's not totally, doesn't make sense. So as you can see, you already saw that. So for application, but it's already terminating too, because it's almost nearly real-time monitoring. Okay, your job is done. Okay, you just done. Scale down to 0. And then, oh, you're gonna keep coming more. Okay, you're gonna to scale up one more time and the other one. Rather than, okay, now I'm scaled to just maximum 10. And then just rebalancing the workloads. That is traditional way. And then with the integration, it's a pretty much easy and efficient way. When I go back to HPA, and then it's the application in the back to the one, it's almost job done, almost took 30 minutes, and then Kata, it's a 0, like I said, 1 to 0, things like that. And then Knative, still crazy because there was just one container application. And then the last thing is Kata, Knative. It's as you can see, it's dynamically. You can see that some of the creating at the same time, terminating, and then running process. It's a pretty much flexible and dynamic behavior along with your event-driven messaging, and then specifically serverless application. So that's the way how do you redesign, keep evolving your reactive application, and then you can say event-driven application, specifically Java, and then Kubernetes plus Knative and Kata. And today I'm going to use Kafka though. And I'm going to a few slides to summarize this talk. So as I mentioned a little bit earlier, so I use today the Kafka source. And then, but you can also use AWS SQL source or Redis streaming, and then RabbitMQ. So we are still working on to make it better, this integration sandbox project. As you can see, you always Kata code to Knative eventing infrastructure. But my goal is I don't care about Knative eventing. I really care about my actual application scale out based on the somewhere event storming or messaging and the serverless behavior. So that's why we are working on to Kata just connect to Knative services directly without Knative eventing. So which means that we can get rid of one layer, which means it's pretty much faster, pretty much flexible in the end. So this is 100% upstream project, even if Reddit and then many our community is give some effort. So which means that we don't have any product at this moment, but stay tuned. So our key bullet point to summary. So Kata is super simple. So I'm not going to rewrite anything, just deploy and then create the scale object. That's it. And then it's auto scale up and down. And then, so the push and pull model, how to connect and control your auto scaling stuff. And then you can also rewrite application, but also Kubernetes resources and manifester whenever you use Knative. That is one of the challenges for developer as well as architect. And the last thing is, as you mentioned, so currently we are focusing Knative autoscale, Knative eventing infrastructure, but we're going to get rid of this and then focus on Knative servicing directly. So here's my YouTube channel. If you're interested, you can watch this video. I actually make a separate full video for each use cases. So maybe you can rewrite, and I put in the GitHub repository if you want to reproduce this kind of stuff. And I keep updating Quarkus version and the relevant the platform version, things like that. And so just, I encourage you to subscribe, and then you can ask me, hey, Dan, I'm really interested in like a GitOps Argo City with the Quarkus or some Java Spring Boot. And I'm more than happy to create some valuable video. So, and then last one, this is a Quarkus thing, Quarkus World Tour. And then here is a bunch of the how to communicate with the Quarkus team, like a community team. We have a Julie chat, and then Twitter, and then YouTube channel, and then GitHub discussion, things like that. And then you already know Eric and I are already Twitter as well. Yeah, feel free to reach out to us. That's it. Thanks for joining today, and hopefully you enjoyed that. Thank you so much.